Sandeep and the Trisha, and we are excited to present our project. Coming to the project that is prediction of heart attack risk using machine learning and the empirical analysis. Uh, Currently, this project aims to build a predictive model that helps to identify individual risks of heart attacks based on the clinical and the lifestyle factors. Coming to our dataset was downloaded from the Kaggle, that is the heart attack protection dataset. It contains the features like cholesterol levels, BMI, blood pressure, and the smoking habits. These apply to the machine learning algorithms, and we achieved the meaningful predictions and insights toward the preventive healthcare. Coming to the data set, here we loaded the data set using pandas, and these are the libraries that we imported. Uh, and the data types, here we used the missing values handled by the imputations. These are the missing values we used over here, and we added the numerical features to scale the data uniformly. And we used the categorical values such as smoking status, and we encoded using one hot coding for compatibility with the machine learnings. Coming to the exploratory data analysis, this is the exploratory data analysis part. In this part, we did the relationship between the features and identify the key predictors. We used the visualization tools like Seaborn and Matplotlib to generate scatter plots, histograms, and the heat maps. Uh, Here we observed the higher cholesterol in this one. We observe the higher cholesterol levels and sedentary hours that are strongly correlated with the heart attack risk. In this analysis, we generated the heat map that shows the future correlation and scatter plots for individual feature analysis. Here we uses the function SNS heat map. Uh, that shows the correlation between the features. And we performed the scatter plots that shows the relationship between the age and the cholesterol that indicates the target variable. Uh, then these are the plot diagrams that we involved in the project. Here, these are the categorical features. Uh, and This is the heat map that shows the correlation between the features. And coming to the data splitting, in this we split the data into 80-20 split, whereas 80% of the data is used for training the model and 20% of the data is used for testing. In general, expert analysis, they do take mostly 70-30%, but for the higher accuracy predictions, we trained the model with 80-20 as well as 70-30, and we got the higher accuracy while we are doing with 80-20. And coming to the model selection, yeah, this is the model selection step. In this, we implemented the logistic regression for baseline performance and the random forest for better feature handlings. And we uses neural networks for capturing some complex relationships. Random forest is performed with the higher accuracy of 90%, and we fit the model using dot fit of function. Coming to the model evaluation, uh, in this, we used the classification report and the confusion matrix shown here. Here we predicted the model accuracy, prediction, recall, and F1 scores for all the classifiers like decision tree and the random forest and the neural networks. The best performance is given by the random forest. Coming to the hyperparameters tuning, here we predict the model with the input values like cholesterol levels, BMI, and exercise hours, and the model that predicts the probability of the heart attack. We demonstrated the input by taking the output values. Here is the model evaluation. We did the classification report using the metrics like precision, recall, F1, and the support. And the paper will continue by the Trisha.
Uh, Hi everyone. Can you share the report if you don't mind, Sandeep? Yeah, thank you. So coming to the introduction, like actually our problem statement is heart is like actually the heart disease is the lead cause of worldwide death. Earlier prediction and detection are critically yet to challenging phase. And here we use the machine learning to predict the heart attack risk accurately. And coming to the background historical context, here shifting from the traditional treatment to the methods to modernize the like predicting tools in actually in earlier 2000s, uh, machine learning came into the healthcare. So we can using machine learning we can accurately uh, like predict the heart attack risk. Here, the key risk factors are hypertension, cholesterol, and obesity, and smoking. Like based on lifestyle, it's smoking, physical inactives, and stress, and socio-economics like incomes and education. Coming to methodologies, like data source used is health, lifestyle, and socio-economics data sets, and machine learning models we have used random forest and neural networks method like machine learning models in this project. Coming to the future selections and pre-processing, data pre-processing, we have identification of critical predictors like I M I sorry BMI and income, and the techniques are cross validation and the normalization. Coming to the data visualization, process of visualization, it highlights the patterns and correlations, and it guides the engineering and stakeholders communication too. For example, histograms for BMI and cholesterol distribution and the correlation heat maps are identified variables. And coming to the results, our model performance is based on like neural networks achieved 88% of accuracy, and surprises the logistic regression is 78% of accuracy. And key importance is key predictors includes BMI and income. Uh, Visual evidence supports the findings with strong data driven arguments. And coming to discussions, and lifestyle modification can reduce the risk effectively. High risk group identified for targeted innovators. And coming to conclusion, and like the summary of the project is machine learning enables the machine learning helps us to enable the precise and scalable risk prediction, and the results align with the medical literature and public health needs too. And coming to the limitations and the future work, we did not implement the real-time prediction interface due to the time constraint. Also, our data set could be expanded for better generalization too. In the future, we plan to integrate the model into the app, like web app, like Flash, using larger and more diverse data.